Okay, so 1.1 is going to be a lot about notations. It's going to be the review, and we're going to talk about real numbers. So properties, different symbols, and we're starting with the different sets of numbers. Okay, so the natural numbers. Solomon, what'd your group put down for that? The natural numbers.
1 to 5 and 1, 2, 3, 4, 5.
Yep, and we're just going to list it. 1, 2, 3, 4, 5. Oh, he's got this, right?
Yeah.
Want to do the second one for me? The integers?
Like -2, 1, 0, 1, and 2.
Great. Okay. And I just put like dot, dot, dot to show it's going to go up, and then here it's going to start. So you have negative whole numbers, positive, and 0. Okay, the rational. Kyle, what's one number you put for the rational numbers? Great. Okay, so a ratio, remember, is just a what? It's a fraction, or it's any number that can be written as a fraction. So even a decimal, like 2.5 would work, because 2.5 can be written as what? 5/2, right? Okay, so anything that can be written as a fraction is acceptable as well. You can also have a negative, be two integers over each other. Okay, it could be a whole number, because any whole number over 1, that would be a ratio. Or what's a repeating decimal that's a fraction? Yeah, so 1/3 it could be written as. Yep. Okay, so any of those are rational numbers. Okay, and then irrational. So I heard a couple of groups talking about E. Did you guys put down E as one of them? Okay, what else did you guys put down? Rather simple. Pi. Yes. And then Brooke, you got another one for me? Yes, great. Okay, so the square roots, when they're not perfect squares, a lot of those are going to be irrational numbers. Yeah, do you have another one? Say it again. Oh, okay. With the irrational, because you have the sign function in it, I'm gonna have to double check that one and see if it is, or if because it's a trig function. Because the answers are rational, right? Yeah. Let me check on that. I put the cube root of 2. I put 3 over pi squared. Okay, and then I'm gonna check to see if we can include trig functions in there. Okay, and then we want to know how we can tell the difference between irrational and rational. So if it is irrational, I think that's probably what you guys put something down for, right? Yeah, Brooke, what'd you put down for that? Yes, yep. So if you can express the decimal as a fraction, it is rational. What did you guys put for irrational? You gonna say anything about the decimals for irrational? The decimals that what? 2 things. Yes, it keeps going. It's never ending, right? So it's a never ending decimal. Okay, and it also can't be a repeating decimal. So it does not repeat. So I thought that's maybe what you'd remember, that it doesn't repeat itself and that it doesn't end. And then if it's rational, it does end, and we say that it terminates. Okay, so terminates or repeats. And I want you to know those two. And then I'm also going to add just it can be written as a fraction. Okay, so if it's rational, it terminates or repeats. It can be written as a fraction. And if it's irrational, it's never ending, does not repeat. And I hope we all feel confident about our symbol for the real numbers. Capital R with the line through it. I taught my Algebra 2 honors kids how to do set builder notation for all real numbers today. And it's so cute when they first learn it, because they're like, oh my gosh, what is she talking about? And then by now you're like, I got that. All right, so then you guys did the property. So the first property says when we add or multiply two numbers, order does not matter. Okay, so if it's A plus B, Sam, can you tell me what you put on this side? B plus A is correct, which means if it's A times B, it's B times A. Okay, and then the associative properties, that means it doesn't matter which two you add or multiply first. So you can always start this as A plus B plus C. If you added A and B together first, now you're adding B and C. You multiply, again, it can just be A, B, C. You multiplied A and B together first, now we're just grouping B and C together. All right, so it's just a different way of grouping. Okay, and then the distributive property, you would have AB plus AC. The order that you write those in, like we just talked about, doesn't matter. AB is the same thing as BA. So if you wrote BA and CA, that's okay. I'm just always going to write them in alphabetical order. Same thing with this. I would write AB and I would write AC. Okay, but if you have BA and CA, same thing. Okay. All right, now at the top of this page, it says that we're going to read through that table, and instead of doing that, I just put it right here on the sheet for you. Okay, so this property where you're multiplying negative A times negative B is equal to AB. That means when you multiply two negative values, what do we know about the result here? When you multiply two negatives, the product is what? Positive. So the product is positive. Okay, stuff you already know. Okay, now when you distribute this negative, okay, they don't become negative. Look and see what happens. The A becomes a negative, the B becomes positive because they're the opposites. So when you distribute the negative, it changes the sign of the term. So I'm going to go over the next chart pretty quickly because these are things you already know. Okay, these are just reminders and you are expected to know these properties. Okay, the first one is just multiplying fractions. We multiply straight across, so it's A times C over B times D. Okay, when you are dividing fractions, you keep the first one the same, you change it to multiply, you multiply by the reciprocal, or you can think of it as keep, change, flip. When you are adding fractions with a common denominator, we add the numerators, the denominator stays the same. Okay, now for this one, if you don't have a common denominator, you have to find the common denominator. So if this one is B and this one is D, what is the common denominator? B times D. So I want you to write what the sum is on the top. And then there was a typo in 5, so we're going to have to change that. Okay, so I want you to come up with the numerator there. So think about, okay, the first one, if there's B in the denominator, what do you have to multiply by to get the common denominator? What would you have to multiply this one by? D. So it's A times D plus, here I'd have to multiply the top and the bottom by B, so plus BC. Okay, and then this one, this should say AC over BC. And if you just want to write it again, right? If you just want to cross that off and write it again, you can. Okay, and then you are going to divide those, and then we'd be left with A over B. Okay, so those are going to divide out. They make 1. That's why we're left with A over B. And then the last one is about cross multiplying. So if you have a proportion, then you can multiply A times D and set that equal to B times C. Okay, so you use that a lot in your geometry days. All right, and the next thing we're going to do is draw a number line, a real number line, and order the following values on it, and we're doing this without a calculator. So before we make our number line, let's decide what values we have to include. So we have negative 5, cube root of 8, 1.6 repeating, 5 over 2, and negative root 5. So the cube root of 8, what does that simplify to? 2. Okay, 5 over 2 is, what's that as a decimal? 2.5. And then let's think about negative root 5. So if you have the square root of negative root 5, we don't know what that is right away, but what's the square root of negative root 4? Negative 2. What would be the next perfect square? After 5. Yeah, 9. And what do we know the square root of 9 is? 3. So this is going to be between negative 3 and negative 2. And what's it going to be closer to, the negative 2 or the negative 3? Negative 2, right? Because 5 is closer to 4 than it is to 9. Okay, so then let's make our number line. So I'm going to start at negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, whoops, 2, 3. It's okay to extend it. All right, and then the way we're just going to mark it down is just put a point on it and then just label it. Okay, so negative 5 is at negative 5. We said the cube root of 8 is exactly at 2, so we'll just put that there. 2.5 is 5 over 2, right? And now we have to do some estimation. So for 1.6, I would say this is about my 1.5. So this would be my 1.6 repeating. Okay, and then this is between negative 2 and negative 3 with it closer to negative 2. So negative root 5. All right, the next thing we're going to review are sets. So a set is a collection of objects, generally it's numbers, okay, which are called elements of the set. Okay, so this is list 5 elements of the set of rational numbers in set notation. So remember we're doing that fancy bracket. Have any of your teachers called it something else? Just the fancy brackets. I just put 5 rational numbers, fractions, 0, an integer. Okay, and then just remember, if you're having trouble with the fancy brackets, you can always do like a sideways seagull, which I had on the board. And then when you guys were little, did you ever like draw pictures with the sun and then the seagulls in here? Give it some ambiance, and then just turn it on its side, right? Those could be your brackets, okay? All right, so what does CEZ mean? This means that C is an element of the Z set, okay, whatever that is, right? A lot of times they're defined like Z would equal something. We'd have a bunch of sets in there. All right, and then once you get that written down, I want you to read the top of the next page, and then there are 2 questions written down there in bold. I want you to answer both of those. Okay, I want you to do that on your own to see if you remember that. All right, so we are going to be using set builder notation again this year. And we use that to describe the domain and also the range. So if you have the domain that's written as x, such that x is greater than 5, this means the domain consists of all real numbers x, such that x is greater than 5. Okay, so write what this one means in words. And then if the domain of the function is the set of all the numbers, how would we write this in set builder notation? So let's check to make sure that we got those written out correctly. Okay, so for the first one, you should have the domain is all real numbers x, such that x cannot equal 1, or does not equal 1. Okay, and then x such that x is an element of the real numbers x. Okay, so go ahead and make any adjustments that you need to make with that. Yeah, so the domain is all real numbers x, such that x cannot equal -1. And if you guys just wrote the domain is all real numbers except for -1, that's okay. Good. Do you guys have questions for me on 1 or 2? All right, then we are going to talk about the symbols for the sets of A and B. So we have the union, the intersection, and the empty set. Do you guys remember what the empty set looks like? Yeah, it's just a O with a line through it. Okay, and that is also referred to as the null set. So there would be no elements in it. Okay, the union is going to be a U. So it's A union B. And this is going to be the set that contains all of the elements in A or B or both. Okay, so I always just circle the or, right? It's everything in A and it's everything in B. Okay, it includes both of those. And then for the intersection, that has to be the set that contains all of the elements that are in both A and B. Okay, so it's elements that they have in common and only the ones they have in common. Okay, so this one here is more restrictive. Okay, the other notation that we're going to talk about this year is interval notation. And then I just want you guys to look at the table below so you can see the different types of intervals, right? You can see the parentheses. Those are going to be non-included values. Okay, brackets are when you do include them. So you have a closed circle, parentheses will have an open circle. Okay, and then the infinity symbol is always going to have parentheses because infinity is not a number, it's an idea. And I did miss an E here, it's parenthesis. You can add that in for me, I appreciate it. Okay, so in this table below, the interval notation is here on the left. Those are the different interval notations. This would be set builder. Okay, and then this is the graph on a number line. Okay, and then once you've looked at that, I want you to go ahead and do this example where you're expressing each of those in interval notation. And you can go ahead and do that with your row. So if you want to try it and then check with your row, you can. All right, let's see how we're doing. Kinley, what'd you guys get for A? Yeah. Great. Okay, so whenever you're doing your intervals, just remember it's always going from the lowest value to the highest value. So if you accidentally flip-flop those around, it's okay. Let's just switch them. Negative infinity is lower than 4, which is why we want that to go first. Okay, so it's x is less than or equal to 4. So 4 is the highest value. The equal to gives us the bracket. The infinity is always going to be a soft bracket there. Okay. All right. And then, Jada, what did you guys get for B? Okay. Good. Okay. And then this one is going to be a soft bracket as well, just because there's no equal to. Okay. So both of them will be in your parentheses. All right, and then this one's going to have a combination of both. So it's going to go from 4 to 5. So 4 is with the less than, so it will be parentheses. That has the equal to, so that's going to be a bracket. Okay, how do you guys think we did? Is it coming back from last year? A little bit? Okay, so if you didn't get to read this yet, we'll go over it together. So we're going to find unions and intersections of intervals, and we're going to do 3 steps here. We're going to write out what the problem means in words. We'll do that together. We'll write the solution interval, and then we'll graph that solution on a number line. Okay, so the word part, I just want you to tell me if it's an intersection or a union and what that means. So the upside down U, that is a what? Intersection or union? Intersection. So the intersection means you have to include the elements that are in both. Okay, so in both -2 to 5 and 0 to 6. There's different ways that you can figure this out. You could list out each set and then you could circle the ones that are the same. I think it's really simple to do a number line and to find where they overlap. So that's usually what I will do. So this is -2, -1, 0, 1. Thanks. Okay, and what I do is I just graph each interval. So from -2 to 5, if they're soft brackets, they're going to be open circles. Okay, and that's my first interval. So -2 to 5. Open circle, open circle. That is open. I know it's small, so that might be hard for you to see. Okay, now I'm going to graph the second one, which is 0 to 6. So I have a closed circle at 0, a closed circle at 6, and then those are connected. And wherever they overlap, that is the solution interval. Okay, and that's for an intersection. So I like to color in the overlap. That's just because I'm a visual learner. Okay, some of you might be able to look at that and figure it out right away. That is okay too. Okay, this I can see that my lowest value is going to be 0. And that is a closed circle, so I have to have a hard bracket there. And then what's my highest value? So it goes to here. What value is that? 5. And then that's going to be a soft bracket because it's an open circle. So step 2 is your solution interval. This is your solution interval for step 2. And then step 3 says to graph the solution interval on the number line. When you're graphing the solution interval, I'm fine if you just put the main values on there. Like if you just do from 0 to 5, that's fine with me. And then you'll have a closed circle at 0. You'll have an open circle at 5. And then that is the graph of your solution interval. Okay, so anytime there's an intersection, you can follow those steps. The next one is going to be a union. So a union has to include all elements because it's elements in A or B. So anytime it's or, what that means is you have to include all elements. All the elements in the first interval and all of the elements in the second interval. Okay, again, I like to see a visual of what's happening here. So this is 2 to 6, this is -1 to 7, so I know I have to go down to -1 and up to 7. Okay, so if I graph 2 to 6, I have a closed circle and an open circle, and I'm going to connect them. So that's my interval 2 to 6. Now I'm going to go from -1 to 7. Okay, and we are not finding the overlap here, okay, because this one is a union. So anytime it's the union, you have to go from the lowest value to the highest value, and that is going to be your solution interval. So the lowest value is -1, and will that be a hard bracket or a soft bracket? Yep, closed circle, hard bracket. And then the highest value is 7. Open circle, soft bracket. Okay, and yes, it just so happens that those are the same. That could happen. It won't always happen. Again, you don't need the visual there. That's just an extra tool to help you if you're getting stuck on some of those. And then we just have a closed circle at -1, an open circle at 7, and then we draw that solution interval in there. Okay, the last concepts we're going to talk about today are the absolute value. So when you're dealing with absolute value, remember that that is the distance from what? 0. And that's why it's always positive, because it's a distance. Okay, so the absolute value of a number is always positive or 0. We write that with an inequality. The absolute value of A would be greater than or equal to 0. Okay, a number and its negative have the same absolute value. That means the absolute value of A is equal to the absolute value of -A. Okay, let's try to work our way through these words. This says the absolute value of a product. So we can just use the values A times B as the product. And it says that is the product of the absolute value. So the absolute value of A times B is the same thing as the absolute value of A times the absolute value of B. So it doesn't matter if you take the absolute value after you multiply or before. And then the same thing happens when you divide. Okay, you can find the quotient and then take the absolute value, or you can take the absolute value of each and then find the quotient. All right, and then I want you to take a couple seconds and do A and B for me. Feel free to check with the neighbor if you're not feeling confident. One more time. All right, what do we get for A? 2 is correct. Okay, so when you do the absolute value, you get 6 minus 4 inside the absolute value, and the absolute value of 2 is 2. Okay, what do we get for B? -1. So this becomes -1 over 1. Okay, -1, absolute value is 1, and of course when you divide, you get negative. Okay, and then the last thing you are going to be asked to do is find the distance between points on a real number line. So the distance, you can either do A minus B and take the absolute value, or B minus A. It does not matter which order you do that in. You also may see, like, find the distance. They might say find the distance like this. So if they say the D and then they have that AB here, that means the distance between those 2 points. So you're going to find the distance between -2.6 and -1.8. Okay, and remember we're doing that without a calculator. So you can choose if you want to do A minus B or B minus A. And just make sure, remember, when you're subtracting a negative, it becomes plus a positive. And then think about what mental math strategy you're going to use to find that. So like if I was doing the 2.6 and then I'm subtracting 1.8, are you guys adding up to that number? Are you stacking them up and doing old school? How are you finding the difference in your head? And yeah, like writing it out, like the 16 minus 8, and then the ones cancel. Is that what you guys are doing? Or some of you counting up, so you're giving me funny faces. So what I would do is I would say, okay, to get from this to 2, I would have to add 0.2, right? And then to get to 2.6, I'd add 0.6. 0.2 plus 0.6 would be 0.8. Okay, or 0.8. And then here you get -0.8, which is also going to be 0.8. There you go. All right, so either one of those methods are fine. We'll get 0.8. All right. I'm going to check the calendar, see what we got going on.